This is the second in a series of videos in which I'm attempting to boot this Mimi 803 vintage computer from some disk images that a gentleman was kind enough to send me. In the previous video I went through trying to boot from that image using a floppy drive emulator, and although it appeared that the floppy drive control circuitry was responding to the data coming from the emulator, and indeed the voltage controlled oscillator seemed to be locking into the correct frequency for the floppy disk type, it still wouldn't boot and it wouldn't read the actual disk. The gentleman in question has been kind enough to send me the file on a floppy disk. Now the only question is firstly whether the format is correct for this particular machine. This is an 803 Mimi and these disks are for an 802, and because we don't have any technical documentation for this machine, or in fact any documentation for it at all, we don't know if it uses the same type of floppy drive and also how compatible the disks will be. But what we're trying to do here is just see if the machine is capable of reading the disks at all. Now because the source of the disks is a bit ambiguous, we're not exactly sure what the data is on the disks and how it relates to these machines. He was kind enough to run off several different versions, and hopefully one of these will either boot this machine or will at least allow the machine to show that it can read from floppy disk. So what I'll do, I'll get the emulator out of the way, I'll reconnect the actual physical drives, and then we'll insert the disks and see what happens. Okay, I've got the drives reconnected. The scope is still hooked up to the test point we were looking at in the first video. It's looking at the VCO clock being fed into the data slicer chip. So in theory the frequency that's shown on the scope should automatically adjust itself when we try to read a disk. So I'll try the first disk. I'll pop that into the drive. It's a bit of a awkward setup here because obviously the machine's upside down and facing backwards. But I should be able to get these into the drive. And this button is attached to the B key on the keyboard. It just saves me having to reach around and try and find the B key each time, or keep rebooting the machine. And on this machine, when you press the B key from the monitor, which is the program that's showing on the screen, then it should try to boot from the floppy drive. So we should now hear the floppy drive start up, which we do. On the screen it's now gone to the boot monitor program, and we're getting the same message, unable to read in this system disk. So I'll try a different disk. So I'll try the next disk. And we'll try rebooting. Okay, now if we watch the scope screen, we can see that the frequency is briefly changing. One thing that's interesting is that with this disk I'm actually getting a different message on the screen, so I'll just move the camera so you can see the message. Okay, so as you can see the message has changed. It's now saying incorrect or blank system disk. I'll just press the B key again, see if it does the same each time, which it does. It's also doing this very quickly, so I suspect it's not even trying to read the disk. I'll leave the camera where it is and I'll swap the disk back for the first one that I tried, and you can see the difference. So I'm just putting the first disk back in. And I'll press the B key again. As you can see, we're getting a different message. I'll press the key again. Also, what's different here is that the response we're seeing on the scope is very different. So I'll move the camera back round and we'll have a look at the way the scope is responding and see if we can figure out what's going on. Okay, so looking back at the machine, I'll press the B key again. Now this is the first disk that I tried, and if we watch the scope you probably can't see the frequency being displayed, but it's going up to about 1.8, 1.9 megahertz. which is too low. So I'm going to try adjusting the VCO and see if we can get it up to the correct speed. I need to do that while it's actually running, so I'll press the B key again and I'll adjust this pot while the disk is being read. Okay, that's taken us up close to 2 megahertz. However, the frequency is unstable, so I suspect this is the wrong format of disk. And as I said, it's not just as simple as having the correct data on the disk, it needs to be the correct format as well. If the headers on the disk are incorrect, then the VCO won't be able to lock in. So although it was reading some data from the disk and the VCO was responding to it, the frequency was unstable. It was varying by quite a large amount. So I'll just swap this disk out and we'll try the second disk and see if that gives us a more reasonable response in terms of frequency. So we'll try again. So as you can see, we're getting very little response now. There is something on the scope, but it's almost immediately rejecting the disk. So it looks like the issue we have here is one of the format of the disk is incorrect, and I don't think it's getting as far as actually trying to read the data. Now, because we're kind of working in the dark here in terms of what the format should be and whether we're heading in the right direction, whether the disk is bootable, I think the best way to proceed is I'll extract the code from the MIMI system ROM. I'll hook up the logic analyzer and I will decompile the code. It will be a fairly simple monitor program, and then we'll look at the logic analyzer, and what I can do then is start stepping through the code, and in theory I should be able to figure out what it's actually looking for from the floppy drive. Without technical documentation, this is really the next step, unless we can find an actual boot disk to try for the MIMI. Otherwise, we could be doing this forever trying to figure out the correct combination, and it may even still be a hardware fault on the computer itself. So I'll get the logic analyzer hooked up and we'll go from there. Okay, so as you can see, I've got the logic analyzer hooked up. This is a Z80 processor, so all I have hooked up at the moment are the address lines, the data lines and the clock. I can always come back and attach other lines later on if I need to. The general intention here is just to investigate what's going on with the monitor program. I won't go into too much detail in this video doing this. I'm sure you're getting bored with the logic analyzer videos, but if you do want to see more of this process, then leave a comment and I'll post another video showing exactly how I go about doing all this. But the first step is to extract the data from the ROM. Now, I'd already done that when I originally repaired the machine. So what I end up with is a binary file with the contents of the ROM. You can see it's fairly straightforward. It's quite small. It's just a small monitor program. Doesn't really do very much. Its main responsibilities are loading the operating system from the floppy disk and the small monitor program that I demonstrated in a previous video. So step one is to take this and I need to decompile it. Before I can do that, I need to convert it into a hex format. This is a Intel hex format. So I do that, I end up with a file that looks like this. I then decompile that, and what I end up with, of course, is the decompiled listing. It's not quite as straightforward as that. What I have to do first is browse through the binary file, which is the first one I showed, which is this one, and look for anything that looks like text. And then when I'm doing the decompile, I create a file that identifies anything that I think is text, and it screens that off from the decompiling. Otherwise it can throw the decompiler off. It's trying to interpret what are just ASCII characters as instructions, and it can scramble the entire decomposition. So I do that, and as I say, I end up with a decompiled file like this. We'll have a quick look at the analyzer. As I said, I won't go into too much detail with this, it does get a bit tedious, but what we're looking at here is this is the start point for the code. Now of course I didn't bother going to the trouble of trying to figure out where the ROM is mapped to. It didn't really matter. It's a small ROM, and so I set the origin at 0 hex. But there are some absolute address jumps in here. The first two are examples of this, and that immediately tells us where the ROM is mapped to, and also where to capture any addresses. Now I could have attached the logic analyzer to the address lines on the ROM and investigate this as if though it was address 0 at the start, but because these are absolute addresses, it's much easier to attach the logic analyzer to the main processor address bus, and that way I can use these addresses directly. Okay, so what we'll do is have a quick browse through this. Now I've had a quick look through this already, and I'll just go to the page that I think is going to be of most interest, and that is this point. And in particular, if we look down through here, we can see this is a lookup table of sorts. It's a decision branch, and what we're doing here is this is the part of the monitor program that determines which key has been pressed. So this really just loops around and around waiting for a key to be pressed. We know the MIMI hasn't booted from floppy disks, so the monitor program is running, and that's what we're seeing on the screen. It's just saying boot monitor version 3, which is what we expected to see, to display. And we know that pressing the B key is going to force the machine to try and boot from floppy disk. If you did watch my video on the monitor program, then this will probably make even more sense. You can see what the commands were that were available, and I demonstrated these in the video. But what we're looking for here is the address it will branch to if we press the B key, and here it's saying F006, which probably looks familiar. If I go back to the first page, the very first instruction was exactly the same. So in other words, at boot up it branches to F006, and also if we try to reboot using the B key from the monitor program, it branches to the same address. So that would be our starting point. We could of course trigger on address, in this case it would be F000, because that's where the ROM is mapped to by the look of it. But I'll move the camera to the logic analyzer screen. I'll set the trigger to this address, and we'll see if we can indeed capture anything at that address. So looking at the analyzer screen, the format I have set up is very straightforward. I've just got the pod A, the first pod, connected to the address lines of the Z80, and the first 8 bits of the second pod are connected to the data lines, and then I'm using the J input as the master clock on both edges. For the trigger, I've got it set to trigger on F006. I don't have any other triggers, it's just purely looking for that address. I could look for a read or a write, but in this case I'm just looking for any access at that address. We can go to waveform, I'll arm the analyzer, and I will now press the B key. Now if the theory is correct, then we should trigger when it tries to jump to the boot up start sequence. So as we can see, it's jumped to where we expected. And what I can do now, you've probably seen me do this before on previous videos, so I won't bore you with this one. I can now go through and see how this code relates to what's in the listing, and then I can go through and see exactly what it's doing, what addresses it's trying to access on the system board, and what values it's expecting to see. And I'm hoping I can find some information that relates to the way it's trying to load the data from the floppy drive, and also the way in which it's trying to access the data on the floppy drive, that is the format of the drive itself. So I won't bore you with the details of this, but if you do want to see more of this, then leave a comment, but it's just really working through the code and seeing if I can figure out exactly what's going on within the machine, and then try and determine what the format of the floppy disk is and why it's failing to load.